Hello students, and welcome back to another geometry video. You know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, we want to describe and correct the error in finding the value of x. And we are told that quadrilateral PQRS is a rectangle. That's important. So, they drew a diagonal of this rectangle from Q to S, and they said that because PSQ is 58, that must mean that QSR is 58, because QSR and QSP have the same measure. Is that true? Is that true for a rectangle? So, what they did is in a rhombus, the diagonals bisect the corners or the vertices of the rhombus. The angles of a rhombus are bisected by the diagonals. In a rectangle, that's not true. We don't know that for rectangles. And in squares, right? Squares are a type of rectangle. They're also a type of rhombus. That works in squares. In rectangles, in rectangles that are not squares, doesn't work. It's actually not true. So, what they did, they applied the rhombus opposite angles theorem to a rectangle. So that theorem doesn't work for rectangles. The theorem doesn't work for rectangles. So that's what they did wrong. The way that they could find angle x is, we know that in a rectangle, every angle is a 90-degree angle. So what we could say is x plus 58 equals 90 degrees. Subtract 58 from both sides, and x is 32. So that's how they could find x. Is they're not equal, they're complementary. Complementary, they add up to 90 degrees. Okay? Wonderful. That's a nice review from the last video. Let's move on to what we have for today. Today we're moving on to the last section of Chapter 7, Section 7.5. This is about trapezoids and kites. So, our learning target is that you know what trapezoids are. That should say are. You know what trapezoids are. And the success criteria is that you can use properties of trapezoids to solve problems. So there's going to be two parts to 7.5. First part is going to be about trapezoids. Second part is going to be about kites. So today, what are trapezoids? How can we use their properties? All right, so let's start off with what is a trapezoid? A trapezoid is a quadrilateral, so it has 4 sides, with exactly 1 pair of parallel sides. 1 pair of parallel sides. So a parallelogram has both sides parallel. A trapezoid only has 1 pair of parallel sides. So we call the sides that are parallel the parallel sides. We call those the bases. And the other sides that are not parallel, we call legs. So the legs are the non-parallel. Oh no, you can't read that. Are the non-parallel sides. Okay. Also, right next to that, I put an isosceles trapezoid. So this is a special type of trapezoid in which the legs, the non-congruent, or excuse me, the non-parallel sides are congruent. So the bases are not, if the bases were congruent, this would be a parallelogram. because we would have, if the bases were congruent, we would have the opposite sides parallel and congruent theorem. So typically, in a trapezoid, the bases are not congruent because then we would have a parallelogram. And a trapezoid is different than a parallelogram. It only has one pair of parallel sides. So the bases are not congruent in a trapezoid. In an isosceles trapezoid, the legs are congruent. Bases are not, but the legs are congruent. Okay, and I'm going to move my head in case you wanted the Spanish version of trapezoid. You can pause it because I'm moving my head back. And we're going to move on to a little bit more information about trapezoids. So, we saw what the legs were, we saw what the base sides were, and we talked about isosceles trapezoids. What we didn't talk about were base angles. So, base angles are pairs of angles that are part of the base side. So we can color code these. So these two angles, the top base angles, go kind of together. We call those the angles of this base. And the bottom angles down here, these are the angles for this base. So base angles come in pairs and they kind of go with the base that they're attached to. So let's read more. Base angles of a trapezoid are two consecutive angles whose common side is a base. So when they say consecutive angles, we can't just say, oh, A and B are consecutive, so these are base angles. Not quite. Their common side needs to be a base. So we're talking about A and D, or B and C, or something like that when we talk about base angles. So a trapezoid has two pairs of base angles. We have the base angles with one base and the base angles with another base. Okay. Awesome. Cool. Yeah, the rest is what we talked about on the last slide. So, let's get into some theorems about trapezoids. So, this slide has 3 theorems about trapezoids. And actually, these are about isosceles trapezoids. So, isosceles trapezoid base angles theorem. Hey, we learned about a base angles theorem for triangles in section 5.4, so maybe this is a little bit similar to that. So it is. Spoiler alert, it is. If a trapezoid is isosceles, so if the legs are congruent, then each pair of base angles is congruent. So if the legs are congruent, then we know that the top set of base angles is congruent and the bottom set of base angles is congruent. Now, I don't like to use the words top and bottom because what if our trapezoid looked like this? Well, then the top and bottom would be the legs, and the legs don't have pairs of base angles. So I don't like saying top and bottom, but I think you get what I mean. It's the angles that go with the base that happens to be on the top in this diagram. Okay, so if a trapezoid is isosceles, then the base angles are congruent. Next theorem is the isosceles trapezoid base angles converse. Oh, so now we're switching the if and the then. Now, if a trapezoid has a pair of congruent base angles, then we know it's isosceles. So it's the reverse of the previous theorem. And the isosceles trapezoid diagonals theorem, a trapezoid is isosceles if and only if its diagonals are congruent. So this is like our rectangle diagonals theorem. If the diagonals are congruent, then I have an isosceles trapezoid, and if I have an isosceles trapezoid, then the diagonals are congruent. This goes both ways. All right, let's make some sense of these theorems by seeing some examples. So, the stone above the arch in the diagram is an isosceles trapezoid. So this is a stone in an arch. Find the measure of angle K, the measure of angle M, and the measure of angle J. Okay, well, I can see that the legs of this trapezoid are congruent. So that means that this is an isosceles trapezoid. This is important because if I have an isosceles trapezoid, then the base angles are congruent. So remember, the bases are the sides that are parallel. So in our case, J, M, and KL are bases. And that means that angle L and angle K are the same, and angle J and angle M are the same. Base angles must be congruent. So I know that angle K is 85 degrees. Measure of angle K is 85 degrees because of the trapezoid. Isosceles trapezoid, base angles theorem. So isosceles, base angles So this says ISO for isosceles trapezoid base angles theorem. We could also just write base angles theorem, and you know that we're talking about isosceles trapezoids. Okay, now we know that the measure of angle M and the measure of angle J are the same. We know that these are the same, but what are they? Well, how many degrees are there in a quadrilateral, right? A trapezoid is a quadrilateral. It has four sides. So any quadrilateral has 360 degrees in it. So if we take these two angles, 85 plus 85 is what? 10 is 170. So if I can do 360 minus 170, that'll tell me what these two angles are. 360 minus 170, I get 190. So together, the measure of angle M and the measure of angle J is 190 degrees. But they're congruent. They're the same. So I can just divide this by 2. 190 divided by 2 gives me that the measure of angle M and the measure of angle J are both 95 degrees. So let me walk you back through how I did that. I knew, this entire trapezoid must have 360 degrees in it because it's a quadrilateral. So that's where the 360 came from. Then I said, I can figure out what J and M are together by subtracting whatever 85 plus 85 is. I suppose another way that we could have done this that might have been easier is if we said, we know that 85 plus 85 plus, right, we don't know what angle J and angle M are, but we know they're the same. So plus x degrees equals 360. That might be an easier way to see it. Then, when I combine like terms, I get 170 plus 2x equals 360. I subtract 170 from both sides, and I get that 2x equals 190. And then I divide by 2, and I see that x is 95. And then, x was angle M and angle J, so those are 95 degrees. That might be an easier way to see it. The other way we did it was kind of like, we did it all in our head and just did a little bit of the math on the paper, like a little bit of the arithmetic. So, For all of these, actually, we used the base angles theorem, and we used the fact that quadrilaterals have 360 degrees in them. So we used the corollary to the polygon interior angles theorem. Ooh, back from 7.1. Okay, let's check and see if we were correct. So, because JKLM is an isosceles trapezoid, congruent base angles, so measure of angle K and measure of angle L is 85. And, oh, we didn't even think of that. Consecutive interior angles are formed because these are parallel lines. We have consecutive interior angles. So we know that these need to be supplementary. Equals 95. So they did it another way. See how many different ways there are to do these problems? That's one of the things that I love so much about Chapter 7. So, measure of angle K is 85, measure of angle M is 95, and measure of angle J is also 95. Awesome. We were correct. Now, let's go ahead and move on to a new vocab word, and we're going to use this in a future example. A midsegment of a trapezoid. Do you think this is at all similar to the midsegment of a triangle from section 6.4? So, the midsegment of a trapezoid is the segment that connects the midpoints of the legs of a trapezoid. So very similar to the midsegment of a triangle. We take the legs, and we take the midpoint of both of the legs, and when we connect them, that's our midsegment. Kind of just like a triangle, except we have 4 sides in a trapezoid. But midsegment is connecting the midpoints of the legs. Midpoints of the legs. Okay, now here's another theorem, the trapezoid midsegment theorem. So, the midsegment of a trapezoid is parallel to each base, so that's important, and its length is 1/2 the sum of the lengths of the bases. So basically, it's if you average the bases together. So if this base is 20 and this base is 10, well, if I add 10 and 20 together, right, if I take 1/2 of 10 and 20, I get half of 30, which is 15. So that's just the average of the two bases. Add them together, divide by 2. 10 plus 20, divide by 2. And, of course, the midsegment is parallel to the bases. That's another very important thing. Is we already knew that the bases were parallel. That's the definition of a trapezoid. But the fact that the midsegment is parallel is very interesting. No matter what, this doesn't need to be an isosceles trapezoid. It's any trapezoid. So the legs, like notice here, the legs are not congruent. BC is longer than AD. So it's very interesting that this theorem works no matter whether it's an isosceles triangle or not. Okay, let's move on and let's do an example with this theorem. So, in the diagram, segment MN is the midsegment of trapezoid PQRS. They tell us that it's the midsegment by putting these congruent marks here. That means that M is the midpoint of PS and N is the midpoint of QR. So MN is the midsegment and we want to find MN. Well, remember, if I want to find the midsegment, I just need to average my bases. So I'm going to do 12 plus 28 divided by 2. 12 plus 28 is 40, divided by 2 is 20. 20 inches. Don't forget your units since they give them to us. So, I have 20 inches. And I can check because 12 plus 8 is 20, and 28 minus 8 is 20. So yeah, because they're both 8 away, 20 is indeed the average of the bases. Awesome, and 20 inches, don't forget your units. Let's check and see if we were right. Okay, MN is 1/2 of PQ plus SR, so 1/2 of 12 plus 28 is 20. 20 inches is the length of MN. Woohoo! We were correct. Awesome. All right, that is all I have for you today. Trapezoids, isosceles trapezoids, midsegments. Wonderful. At this point in the video, I think you know what time it is. It's time to assess your understanding of the learning target and the success criteria. So, do you have a question that is missing a puzzle piece that will turn it into a light bulb? Right? I like this picture because it symbolizes that sometimes our questions can give us what we need to have that light bulb moment. I can ask a question and then, oh, now I understand, right? Questions can be the puzzle piece to understanding sometimes. So there is nothing wrong with asking questions. There's nothing wrong with having questions. Questions are good and they help us understand. So, where are you on this scale? Do you know what trapezoids and isosceles trapezoids are? And can you use them to solve problems? Can you use their properties, the theorems that we learned about in this video? Can you solve problems using the theorems? If you are confused, that's okay. Questions are the path to understanding. If you're a 2, if you're like, maybe, I don't know, it's time to try the homework, and that'll uncover some of the questions that you have. And if you're a 3, and you are feeling good, feeling great, ready to do the homework, then make sure to help your friends, help your classmates, help your siblings, whoever needs help. All right. Here are some practice problems that you can do to practice the skills that you have learned in this video. Be sure to do the problems that your teacher assigns as well, of course. And, as always, let's end with a launch. Today's launch comes from Melody Beatty. I hope I said her name right. And she says, gratitude unlocks the fullness of life. I like this. It's a very simple quote, but I like it because being thankful kind of leads to a full life. If you want your life to be full, right, it means that you're satisfied with your life. You have everything that you want out of life. That's what makes life full. So if you have everything that you want, like the more gratitude you express, the more, like the attitude, if your attitude is more grateful, you're more thankful for what you have. And when you're more thankful for what you have, life feels a little more full. So try gratitude, see if it unlocks the fullness of life for you. So that is my lunch for you today. Take it with you as you go throughout your day. Have a wonderful rest of your day, and thanks for being here. Thanks for watching. Bye.